and actually prove to ourselves that this is a true statement. And so first I want to look, what is the tangent according to this theta? Opposite over adjacent, so 4 over 3. Good. All right. So we want to know if we get the same thing when we figure out what all this mess is. So first we want to look at what is sine according to theta. So looking from theta, what is the sine ratio? 4 over 5, opposite over hypotenuse, so that's 4 over 5. And then we can figure out cosine according to theta. So what's the cosine ratio according to theta? 3 over 5. Good. Adjacent over hypotenuse. That's 3 over 5. And what I've created here is a complex fraction. How do we deal with that? Yeah, you multiply by the reciprocal, right? Keep change flip. Keep change flip. So this becomes 4/5 times 5/3. What happens to those 5s? They cancel out. And what do we get? 4 over 3. Oh, look. It matched. Oh, it is a true thing. How about that? Okay. So numbers are kind of nice for proving those kinds of things. But anytime we see sine over cosine, sine theta over cosine theta, we can replace it with tangent of theta. And we do that a lot. Okay. So if you know that tangent of theta equals sine over cosine, what's cotangent of theta? Yes, cosine over sine. Okay. It can, again, because they're reciprocal, so all you have to do is flip the fraction. So how do you remember? These are the ones you really want to make sure we know and love really well. Here the cos are both together in the numerator. You can think about it as, let's see, cos on top. Tangent and sine are alphabetically closer. So tangent is sine over cosine. I don't know. Those are things I think about. All right. But you got to come up with some way to remember that because you have to memorize these. Okay. All right. You good so far? We're doing really good. This is the last thing, but it's going to be like 2 pages.
What? You're a liar.
No, really, I'm not. I'm giving it to you straight, my man. All right. The Pythagorean identities, this is trig in a nutshell. All right. Everything we're going to do is based upon this right here. We're going to graph based on this. We're going to simplify algebraic expressions with this. Everything we do is based on this right now. So I'm going to introduce it today, and then we'll do a lot more with it in a little while. So this is our lovely acute angle theta here. And we dropped an altitude and turned it into a triangle, which gives me this leg length of x, a vertical length of y, and again, I'm going to call that hypotenuse r for the reading. And the Pythagorean identities, this is definitely something you must know and memorize. And what I'm going to do here is I'm actually going to derive it for you. And my calculus teacher derived it for us. It's actually a really easy sort of proof. But the nice thing is you're going to build on what you know, and then you never have to memorize it because you can just do it again. Okay, because you'll see it's pretty good. So it's called the Pythagorean identity, which makes you think of what? The Pythagorean theorem. Very good. So based on this triangle, what could we write to represent the Pythagorean theorem? X squared. Good. X squared plus y squared equals r squared. Excellent. Great starting place, and you all figured that out, right? Okay, good. So one thing that we really like to do in math is make things turn into one. All right, and it turns out that if we can make something morph into a 1, life becomes really, really nice. So I'm going to start by dividing everything through by r squared. And if I do that, what is r squared divided by r squared? 1. Hey, look at that. 1. And y squared over r squared, I'm just going to change the formatting a little bit, but is it the same thing to say y over r quantity squared?
Yes.
No, yes. Good, good, good. Okay, so yeah, this would be y over r times y over r, which would give you y squared over r squared. Okay, which means x squared over r squared can be rewritten as x over r quantity squared. Very good. All right. Great, you're doing so good. All right, so now I'm going to go back to my triangle here because I have angle theta. That's really, really important. And when I look at x over r, that's a ratio, and it's a very specific ratio. Which ratio is that? Cosine, because this is adjacent over hypotenuse, right? So x over r is really the cosine according to theta ratio. All right. Well, what's y over r then? Sine, yeah. Opposite over hypotenuse. So that's actually just the sine ratio. Sine according to theta squared. My pen is dying. So, okay. And then we just learned this notation. This is the longhand. I'm just going to clean that up a little bit, and we write cosine squared theta plus sine squared theta equals 1. This is the big kahuna. This is the one you must memorize. Cosine squared plus sine squared theta equals 1. And that is our first Pythagorean identity. And what's nice about this is it comes in many, many, many forms. So, for instance, is sine squared theta equal to 1 minus cosine squared theta? Is that true? Yeah. Why is that true? What did I do? I just moved the cosine over. Sure. Could I also say cosine squared, whoops, I don't know what I was reading there. Cosine squared theta equals 1 minus sine squared theta? Sure, again, I just moved the sine squared over. Great. So you can rearrange these identities. And then, yeah, it turns out that if we take cosine squared and add sine squared to it, it's going to equal 1 all the time. Kind of interesting. All right. So now what I'm going to do is I'm actually going to take this cosine squared theta plus sine squared theta equal to 1. And again, I want to do that whole like divide through thing. So I'm going to start by dividing through by cosine squared. I'm going to divide everything through by cosine squared. Again, with that whole idea of creating ones in different places. What is cosine squared divided by cosine squared? 1. Oh, good. All right. And with the same idea here, I could rewrite this fraction as sine of theta over cosine of theta, and it's being squared. Is that true? Is that okay with you? Yeah? Okay. And then same idea here, 1 over cosine of theta is really, the whole thing is actually being squared. We just learned this. What is sine theta over cosine theta? Tangent. Hey, how about that? Tangent of theta being squared. And what is 1 over cosine? Secant. Secant. Very good. Secant theta. And it's being squared. And again, this is the old school notation, so just moving that power. So tangent squared theta is equal to secant squared theta. And this is the second Pythagorean identity. And again, it just came right from this original one and dividing through. So I do have a little mnemonic for this one. To help you remember, I learned this from a student. 1 adds a tan by the C. 1 adds a tan by the C. A tan, like, right?
So are these going to stay the same, like forever?
We're going to use them all.
Or is it just for the problem right there?
So we're going to see this come up in lots of different ways. But, and we can rearrange it too. So well, 1 is equal to secant squared theta minus tangent squared theta. So I can rearrange that one just like I did with the first one. That's different. 1 adds a tan by the C. That's how you remember that one. I have no special mnemonic for the first one. I don't know. You just have to know that one. Okay. All right, but wait, there's more. All right, there's more because we're going to go back and it happens one more time here. And we're done. And then sine squared of theta equals 1. So we're going back to our big kahuna here. Cosine squared plus sine squared equals 1. And again, I want to divide through. What am I going to divide through this time? Yeah, I want to, again, make that 1 appear in a different spot. So we're going to divide through by sine squared everywhere. I haven't used purple yet. Okay. So again, cosine squared theta over sine squared theta. That's really just cosine of theta over sine theta, quantity squared. And what's sine squared over sine squared? 1. And 1 over sine squared is really just 1 over sine, quantity squared. And again, we just learned this. What is cosine over sine? Cotangent. Yeah, so this is cotangent. Whoops, cotangent. Can I just write cotangent squared theta? Yeah, okay. Plus 1. And this is 1 over sine. What's 1 over sine? Cosecant. Cosecant. So cosecant squared theta. Very good. So that one, that's our last one. So there are 3 Pythagorean identities. You must know the first one. And the other 2, you can, I have special ways to remember them. So the second one is cot plus 1 equals cozy. Cozy, like cozy, cosecant, cozy. Right? Cot plus 1 equals cozy, like your camping cot. So that's how I remember that. And again, you can rearrange that at will to create all sorts of different identities. And we use identities, we'll use them a little bit later, but we'll use them like a substitution. So I'll see something like cosine squared plus sine squared, and I can remove that whole thing and replace it with 1 because they're equal to each other. Okay. All right. You have questions for me? All right. Good job. Here you go. Class practice 5. You will need to take it home and finish it today, I'm sure.
I need to double check.